Welcome to our tutorial on implementing predictive analytics using Apache Spark. In this video, we will explore how to leverage the power of Spark's machine learning capabilities to make predictions based on your data. We'll dive into setting up Spark, handling data, building a predictive model, and interpreting the results. Let's start by installing Apache Spark. You can download it from the official Spark website. If you're using PySpark, make sure you have Python installed as well. You can also use tools like Anaconda to manage your Python packages effectively. Once you have Spark installed, we need to set up our environment. You can use any IDE of your choice, but for the purpose of this tutorial, we will use Jupyter Notebooks. Let's create a new notebook and import the necessary libraries. Now that we have our Spark session ready, the next step is to load our dataset. For this tutorial, we'll use the popular iris dataset, which contains features of different iris flowers. You can download the dataset from the UCI machine learning repository. Let's take a quick look at our data to understand its structure. We would like to explore a sample from this dataset before we perform any operations. Here we can see that the iris dataset contains columns for sepal length, sepal width, petal width, and species. For our predictive analytics model, we will treat species as the label we want to predict. Next, we need to perform feature engineering. This process can include converting string labels into numerical formats, scaling numerical features, and vectorizing our data. Spark's mlib provides a class called stringIndexer for encoding string labels to numerical format. In addition to label indexing, we will also need to assemble our features into a single vector before training our model. The vector assembler class can help us achieve this. Let's view the transformed data frame to ensure that our operations have been successful. This will help us confirm that the label is correctly indexed and that our features are in a vector format. Now it's time to split our data into training and testing datasets. This will help us evaluate our model's performance later. We'll use an 80-20 split. With our training and testing datasets ready, it's time to choose a machine learning algorithm for our predictive model. In this case, we will use the decision tree classifier. Let's import it and initialize our model. Now we will train our model using the training dataset. This is where the magic happens as Spark builds a decision tree based on the training data. Once the model is trained, it's important to evaluate its performance using the testing dataset. We will use the model's transform method to make predictions on the test dataset. Let's review the predictions along with the actual labels to assess how well our model is performing. To quantify our model's performance, we will calculate the accuracy using the multi-class classification evaluator. Now that we have the model's accuracy, we can further analyze the results. It's also possible to visualize the decision tree, which can provide insights into how the model made its decisions. Let's extract the tree model and visualize it using Matplotlib. As a closing note, predictive analytics with Spark can greatly enhance your data-driven decision-making processes. Whether you're working with classification tasks like the iris dataset or regression problems, Spark's powerful capabilities can help streamline your workflow. Thank you for watching this tutorial on implementing predictive analytics with Spark. Don't forget to like, subscribe, and hit the notification bell for future content. Any questions or comments, please leave them below.